at right angle to each other. The de Broglie wavelengths are lambda 1 and lambda 2 respectively. The particle suffers perfectly inelastic collision. That word is very important. Inelastic collision. So what do you mean by inelastic collision means? So both the kinetic energy are total energy and momentum is not conserved. Such a type of collision is known as inelastic collision. The de Broglie wavelength lambda of the final particle is given by, if I consider a particle of mass m1 is moving like this direction, if I consider one more particle of mass m2 is moving like this direction, the angle between two particle is 90 degree because they will give. So two particle moves at right angle to each other. So those particles might collide. After collision, the effective momentum is given by, I can consider as a P. What they are asking to calculate? So calculate de Broglie wavelength of the net particle after inelastic collision ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. So first of all I can consider, so de Broglie wavelength is calculated by using the formula for first particle. I can consider lambda 1 is equal to h by p1. h by p1. If I consider this is the equation 1. So for second particle lambda 2 is equal to h by p2. So I can consider, so this is the second equation. So therefore lambda 1 is equal to h by p1 and lambda 2 is equal to h by p2, but in terms of momentum, so we can write, so p1 is equal to h by lambda 1, p2 is equal to h by lambda 2. p2 is equal to what? H by lambda 2. So therefore according to conservation of momentum, the net momentum is given by, according to conservation of momentum, the p net, because after inelastic collision the net momentum p net is equal to, so the square root of p1 square plus p2 square plus 2 into p1 p2 into cos theta. So the angle between two particles of masses m1 and m2 is 90 degree. So therefore what is the value of cos 90? 0. 0 into p1, 2p1 into p2 becomes 0. So therefore net momentum is equal to square root of p1 square plus p2 square, square root of p1 square plus p2 square. So the net momentum is equal to h by lambda. H by lambda here is equal to square root of p1 means h by lambda 1 whole square plus p2 means h by lambda 2 whole square. Take h square common and root of h square is h. So therefore h get cancelled. So therefore 1 by lambda is equal to, so root of 1 by lambda 1 square plus 1 divided by lambda 2 square. So therefore 1 by, so squaring on both side, ಎರಡು ಕಡೆ ಮಾಡ್ಕೋಣ, ಸ್ಕ್ವೇರ್ ಮಾಡ್ಕೋಣ. ಸೊ therefore 1 by lambda square, so root square ಮಾಡ್ಕೊಂಡ್ರೆ becomes 1 by lambda square 1 square plus 1 by lambda 2 square. So therefore 1 by lambda square is equal to 1 by lambda 1 square plus 1 by lambda square. So therefore the correct option is option A. So whenever two particles are moving with perpendicular with each other, after collision the net momentum is given by p net is equal to h by lambda, because net momentum, net wavelength they are given lambda. So finally the correct option is what? Option A. So next question. So So go through the question. The electric field of light wave is given as E is equal to 10 power minus 3 into cos of 2 pi x whole divided by 5 into 10 power minus 7 minus 2 pi x of 6 into 10 power plus 14 into T into Newton per Coulomb. The light falls on the metal plate of work function. They are given work function, how much they are given? 2 electron volt. So therefore work function can be symbolically represented by W is equal to 2 electron volt. They are asking to find out stopping potential. So V naught is equal to question mark. Again I can write the same equation. E is equal to 10 power minus 3 cos of 2 pi x divided by 5 into 10 power minus 7 minus 2 pi x into x 6 into 10 power plus 14 t 10 power plus 14 t. So equation is somewhat wrong. So 2 pi x whole divided by 5 into 10 power minus 7 minus 2 pi into 6 into 10 raised to plus 14. So this one x into, so this one x and into 10 power plus 14 t. So that equation is compared with a standard equation. E is equal to E naught into cos of kx minus omega t into x bar. If I compare, so given equation with standard equation, instead of given E naught, they are given E naught badlagi 10 power minus 3 they are given. Instead of given k, they are given k is equal to 2 pi by 5 into 10 power minus 7. So we know that k is equal to 2 pi by lambda. K is equal to the standard equation. K is equal to 2 pi by lambda. Instead of given lambda, they are given 5 into 10 power minus 7. So wavelength 5 into 10 power minus 7 meter. So they are asking to find out in stopping potential. So by using Einstein equation, so we are going to get Hc by or incident energy is equal to work function plus kinetic energy. Work function plus what? Kinetic energy. So therefore maximum kinetic energy E maxima is equal to E minus W. E minus what? W. So therefore Hc by, so E maximum badlagi we can consider E into V naught in terms of what? Threshold potential or stopping potential. So Hc by lambda minus pi is equal to kinetic energy, so maximum kinetic energy. So therefore E is equal to Hc by, so they are given one data is missing here. So here E is equal to 12.375 whole divided by lambda in Armstrong. So this is the standard formula. So E is equal to h nu. If we substitute mu formula Hc by lambda, all the data we can substitute. Finally we get 12375 whole divided by lambda in terms of what? Armstrong alidre matra. So therefore Hc by lambda minus pi into kinetic energy or Hc by lambda is equal to 12375 whole divided by wavelength 5 into 10 power minus 7. So therefore Hc by lambda is equal to 12375 whole divided by lambda means 5 into 10 power minus 7. So they are given in terms of Armstrong. So therefore 12375 whole divided by 5000 Armstrong. don't write 5 into 10 power minus 7 because that standard formula comes in when wavelength is in what? Armstrong. So therefore my final formula to calculation of threshold wavelength is hc by lambda minus w minus ev naught minus what? ev naught. hc by lambda means 12375 divided by lambda 5000 minus work function. How much they are given? 2 into ev is equal to e into v naught. Here also electron volt is there, e get cancel. So we know the value. So 12375 volt divided by 5000 is there. So first we can simplify the value. 12375 volt divided by 5 into 10 power plus 3. 5 ones are 5 twos are 10, remaining 2 for 23. 5 fours are again remaining 3, 37. 5 sevens are again 5, so 5 fives are, so minus 2 is the volt into v naught. So therefore 2475 into 10 raised to minus 3 minus 2 is equal to v naught. So ಪವರ್ನ ಶಿಫ್ಟ್ ಮಾಡ್ಕೋಣ 1 2 3. ಸೊ 2.475 minus 2 into is equal to v naught. Subtract that value. 0.475 is equal to v naught. That 0.475 that is approximately equal to 0.